Thanks. Thanks, everybody, for coming. I know it's early. It's the last day of the conference. It's the more community-organized one. It's a little hard to know when you should get there. I was sort of curious how many people are in the audience. If you could please raise your hands. I just want to get a count. 1, 2, 3, 4, 5, 6, 7. Keep them up. All right, great. Good. That'll go on my trip reports. I counted about 5,000. So Fernando Chet Haase, I hope I'm pronouncing that correctly, unfortunately couldn't be here today. There was a keynote planned. It was going to be amazing. It was going to be about Scala. When he couldn't show up, I offered to slot in to fill the time and the space and to waste your time. And then I realized that the problem was I don't know a damn thing about Scala. And that was really going to be a complete waste of time. So instead, I'm going to talk about something completely different. Also, it's not going to be him. It's going to be me. So I would like to talk to you about practical best practices in our industry. I am Chet Haase, of course, and this is a practical guide to practical best practices for practicing software practitioners of software development practices. So I am obviously a consultant. I am a process methodologist. I have various titles in the company that I run. There are some of them, and there's another one. I run a company called Process Methodology Strategists, or PMS. I'd like to tell you a little bit about PMS. Some of the services that we offer include consulting. We offer management as well. We offer management consulting. We also offer management services, sort of combining these things together. And of course, management consultant management. And finally, consulting management. And finally, management, which obviously costs a lot more because there are more letters. Now, I understand that the prices probably don't make sense to you here, so I wanted to offer that we do now have these available in euros as well. I'm not sure how the exchange rate works out, but we can follow up afterwards. So there's a classic quote called "Practice makes perfect." I don't know who said it. It doesn't matter because it wasn't me. I have a quote that I prefer, which is that practices make perfection. I prefer this for a couple of reasons. One is that it's talking specifically about software practices, which I think is more interesting and more relevant to us than simply the generic idea of practice. Also, it's my quote. So practices do make perfection, and I want to prove this by offering a little bit of data. I think data is really important in our industry. So if we look at this, this is abstracted from some work that we did with clients. If you look at the amount of time that the client actually spent practicing, then you can see that over time they achieved more perfection. I think the data is really clear here. And obviously it's a chart, so there are numbers that back this up. So you can just take my word for it. So I would like to offer another quote here. So practicing practical software development practices make more perfect software development practices. I think the key idea here in this quote by me is that it's not important enough to simply practice. We are talking about software development practices, so it's important to practice software development practices, right? It's that meta level. It's that extra step that you can take that brings you the perfection that we're all looking for in our industry. And once again, I'd like to offer a little bit more data. This is from another client that we worked with, and they practiced not just this generic concept of practicing, but they actually practiced practical practices over an entire year period. And you can see that they achieved 100% perfection through that entire year simply by practicing practices, except for the month of August because this is Europe. So I want to walk through a couple of things in this presentation. One is some of the traditional best practices that we have, and then how those can apply to you, and some of the newer best practices that we can talk about, and how those can improve your software development practical best practices practitioning. So first of all, some of the traditional best practices. I think we all agree that code generally needs comments, but I don't think comments are enough. I think of it as commentary. If you're talking about comments, it's just a few words, some random explanation of something, and it's not necessarily useful. I think of comments as the ability to tell a story within the code and really help everybody understand exactly what's going on. So for me, it's not comments, it's commentary. So here we have an example. There's a simple getter here. It's a function that's called getCalculationResult, and it returns an internal variable called calcResult. Seems straightforward. Maybe we don't need comments. I disagree. What is calcResult? What are valid values? What should we expect to get from this? What went into this code internally? There's so much that we could explain about this, so this is where comments come in handy. First of all, you want some implementation details for the people that are going to be charged with maintaining the code in the future. Okay, so what went into this? There's a floating point value. There's a field on this object. It may be undefined in some cases. What are the relevant bits that the code maintainers are going to need to know about? And then things change over time, right? In any software project, you don't simply ship the code. You maintain the code. You make fixes in the future. When you make those fixes, you should provide that information again to future maintainers. So I came back to this getter later, and I realized, oh no, there's an off by one error. And so I made a comment and said, hey, there's an off by one error here that I needed to fix. And then I came back several months after that, and I realized, actually, it wasn't an off by one error. It was an off by two error. So again, I just left a comment to that effect. And then several months passed, and I came back to the code again and realized, no, actually, I was right the first time. It wasn't an off by two error, so now there was an off by -1 error. And again, you just sort of leave this running commentary so that when I return to the code to then fix that bug in a few months, then I actually know the history of what's going on there. So that's not sufficient. That's all the implementation details. But what about the people that are actually calling this getter? What can they depend on? What is the information that they need to extract from this? So then you need to add a little bit of comments around the method itself. So obviously, you want to note the author, especially if it's me, so that people know to come back to me, and I can bill them for maintaining this code in the future. You want some other references. Where else can we see information that relates to this? What are other getters and setters? What are other methods that people should know about? What about Wikipedia articles? What about good libraries with referenced documentation and books that people could go research to learn more about this important getter? You also want to know what's going to happen exceptionally. So what is going, what kind of exceptions are going to be thrown by this code if the result is bad? That's obviously important. What are the return values that can come from this thing that's going to return? Sure, it's just a float, but what does a float actually mean? Right? What kind of precision do we have here? What is the totality of information that they can derive from this? What could, you know, I think at a very sort of ignorant level can look like a simple floating point value. Nothing in software is simple. And then we have header comments that actually explain, OK, here's what's going on in this getter. Here's a bunch of information that you probably need to know as a caller. And then one final thing is you should probably have a comment at the top that says the method name, because although it is below, it sort of got lost in the noise. All right, another best practice is naming conventions. I think that clarity of naming can provide information that makes code more obvious when you're just reading the code. Sure, comments are important and commentary even more important, but also just communicating that information just by the way that you name things in the code is kind of critical. It makes the code easier to read and easier to maintain. It increases the level of obviousness in the code so that you don't need as much explanation. So I want to give an example of some of the code that I wrote for a client here. So here we have a method called Chet #1. Chet, obviously, it's a very clear name saying that I wrote that code. So once again, the client knows who to come to have them bill for maintenance of the code later. #1 is another thing that's very clear. That was the first method that I wrote on that day or in the file. Maybe that month. I can't remember now. We need some more comments around here to clarify exactly what I meant by #1, but it made sense at the time, and I think that's the important thing. There are a couple of parameters here, and I want to point out something very important here in the parameters that OK, I'm going to stand here. I like to use punctuation in parameters to help specify what's going on here. So we can see that there's an exclamation point by the X, there's a question mark by the Y. Indeed, why? What is going on there? Right? So the exclamation point means to me, when I read this code and when I wrote the code, X is really important, and I want everyone to know that. That is a critical parameter in this method. On the other hand, Y is being passed in, but honestly, I was never quite sure what was going on with it. And so putting a question mark there calls that out to the reader to say, the author didn't really know what was going on here. And that's sort of important information to pass along. And then we have this who knows parameter. Once again, it's based on a value of Y, and we're dividing by this value that I didn't understand to begin with. So obviously, I don't understand with what's going on with who knows either. So naming of the variable, who knows, and then the question mark sort of, again, re-emphasizing that point that the author didn't really understand what was going on. And then we call the Chet number 7 method, which was the 7th method I wrote on that day, or in that, actually, no, it was the 8th, but then I had deleted the 7th, so then I did a refactoring to rename things. So Chet number 7 is a really sensible name to put there. We call it with who knows, question mark, and we call it with a Boolean value that I called writes with an exclamation point because I was very sure what was going on with that specific parameter. Simplicity is so important in code. It makes things easier to write, and it makes them easier to read and to understand. And I want to emphasize the importance of story in terms of simplicity and in terms of understandability. I think humans, as a culture, as a biological being on the planet, really think in terms of story, right? It's not enough to just know the facts of a thing, to know numbers and digits. It's really better to understand the context of how things happen. So I try to write my code and my presentations in terms of story so that people really understand the totality of what's going on, all of the context surrounding it. I want to give you an example here. So this is some code that I wrote for another client here. Bob and Marianne go to the store. Now, I want to point out, I'm a big fan of go-to. I think we all are. It helps you go to, just jump immediately to a place in the code. However, the problem with go-to comes from not jumping to a place in the code, but rather jumping to a random place, right? If I jump later in that file or some other file entirely, then it's a little difficult to figure out what's going on in the code. So I just jump to the next line. So we go to the store, and the store is just on the next line. It's really clear. So Bob and Marianne go to the store. Who shot Bob? Question mark, right? And then we have this 0:0. Syntactically, it means nothing. But I like the way it looks, and I think that's a lot of the important elements of the story is just that feeling of friendliness, of interest, of syntactic interest here. Culprit, obviously, is going to be Marianne, because we all know Bob, he's a jerk. And then why Marianne? Again, question mark. Punctuation is so important in communicating meaning in language, in culture, and in code. And then finally, 0:0, again, because I like it. Now, it's important to point out that there is no language that supports the kind of punctuation and syntax that we're talking about here. So we had to build that ability for the language to support that. We basically created a new language compiler, interpreter, and runtime, and then build the clients appropriately for years. Portability, very important in software, obviously. Platforms are very diverse, more and more. We have multiple mobile platforms. We've got desktop platforms. You've got server. You've got things in the future, things in the past. And all of these things continue to change and evolve over time. And what we really want is code that is going to work everywhere. All of the platforms that people might want to run it on now, as well as the platforms that are going to exist in the future. So here's an approach that we took with another client. Just like GoTo, I'm a big fan of BASIC as one of the most important computer languages. And unfortunately, BASIC doesn't really exist on a lot of current platforms, but I wanted to use it anyway because of the clarity, because of the simplicity of the language. And so we wrote a BASIC compiler and runtime so that it could support things like this. So I wanted the ability to have this fantastic program, one of my favorites since childhood, that will take that word and just emit it over and over infinitely. Very powerful functionality. I wanted to add the eval capability from JavaScript, which is really powerful. Take an arbitrary string and then just run it, because what's the worst that could happen? Now, once again, this was not supported by anything out there that was running. Basic wasn't there. It didn't have the eval thing. And once again, we were able to build a client for doing this work, for creating the language, for creating the compiler and the runtime and all this stuff. And we did it for all of the platforms on which this works, 286, 386. We never quite made it to the Pentium or the processor families after that, but we're working on that, and we'll build them appropriately. We'd like it to work on mobile. We'll get there eventually. We have it working on some mainframes. We needed to port this to all of those different platforms, which took obviously lots of time and tons of billable hours. But when we finally did that, after doing all of that work to port all of the infrastructure bits, then we were able to run this same set of 3 lines of code on all of those platforms. So it's really magical. I would urge everybody to consider this level of portability for powerful software integration. Speaking of integration, continuous integration, obviously really important. The ability to build and test and do it over and over again requires more storage. It requires servers to do all this work, and it requires more bandwidth. And I want to point out that all of this means larger IT budgets and really, really big consulting contracts. So very beneficial. And you can see how important it is by the number of times that that text blinked. Testing, clearly important. When you build tests, you build confidence. When you build more tests, you obviously have more confidence. And finally, when you build even more tests, you have even more confidence. But of course, you're not going to trust me. You want to see the data. So here's some. I think that's pretty clear. All right, so here's an example. So we had to do some testing for a client. So we wanted to test what this method was going to be like. So we created this method test. And we thought, well, we want to call it with different parameters. So we created different versions of this test. And then we wanted to run it in a loop and really sort of hammer on it and make sure that it was running very well. So then we had to structure that inside a loop. Well, now it was getting really complicated. We had all this code and all these different tests just to test these different levels of parameters for this one method. So then we needed a test framework. Now, there were different methods in here. There were hundreds of methods. So, of course, we needed to create one of these for all of those, and on and on and on. And then eventually, what you really need is a framework for your framework. And then, of course, it wasn't just this one file, one set of files. It was several modules that we needed to deal with. So then at that point, clearly, we needed a framework for the framework for the framework. And again, billable hours, right? It all comes back to how much you can actually make from your clients to provide them the level of confidence that they need to then report to their management and say that they are doing their job. So process, clearly important. Process is, in fact, my middle name, as everyone knows. I had it legally changed. It's a dependable routine for developing, testing, and shipping the product. And again, just like many of the other things I'm talking about, requires many more billable hours, many more. So I want to take a break now, and I want to talk about quality. I want to talk about quality. I want to talk about quality. And see what we can explore in the software world here. First, there's the first law of software quality. The more code that is written, the more bugs there are. And again, this is a quote from me. You can express this mathematically, which is important. We're all scientists here, which means we probably had a math class. So I think this will appeal to you. Errors equals more code squared. And I think the exponent is really important because that helps it look like a real math equation. Now, you can abbreviate this into something that looks more familiar. It just sings to me. It really calls out. I'm not quite sure why. Second law of software quality is, of course, that the more bugs there are, the less quality the software has. And this is kind of an interesting corollary from the first law. They really work very well together. So I want to take a look at an example here. So here's a file, tons and tons of codes, and I want to look at the software quality metrics for this file compared to the one on the right, which has 0 lines of code. So we can look at a couple of interesting metrics here. First is the number of bugs. Now, You can tell by the fact you can't actually see the code here. The font is really, really tiny. But you can tell just by the fact that there is code in there, there's probably more than 0 bugs there, right? I think you could just sort of do that by inspection. Whereas, how many bugs in the code on the right? Anybody? Anybody? Nice, nice. 0. Someone's been listening. That's fantastic. Yes. By definition, 0 bugs because 0 amount of code, right? Now, we can also just look at the measurement, this quality metric measurement, and we can say the one on the left definitely has worse quality. Why? Because probably more than 0 bugs, whereas the quality of the one on the right is objectively best out of these two, right? Certainly better. It's always better to have fewer bugs. You can represent it graphically with this pretty green check mark here as well. So again, we can look at some important data here. You can say that as the amount of code goes up in a project, so does the number of bugs. Now, if you want to look at it another way around, it looks like this. And again, you can look at a different way of slicing this. You can say, well, what about if we're talking about not just like an arbitrary, vague sense of code, but you want to look at the number of lines of code? Well, then it looks something like this, right? But what if you want a different perspective on that data? Similar, right? We just keep getting the same information over and over and over again. The more code you have, the more bugs you're going to have. So I would say, as a consultant, and I'm not even billing you for this one, but I can, that the path to better software quality is that in order to get higher quality, you need to create fewer bugs. And in order to write fewer bugs, you need to write less code. So how do we find the path to writing less code in our software projects and companies and organizations? So there's a couple of different approaches I want to talk about. First of all, hiring. I want to point out that as the number of programmers goes up, so does the amount of code. But as the number of non-programmers goes up, the level of quality raises, right? So the more people that you have in your organization that are specifically not writing code, then proportionally the higher the quality is of the code that you're shipping, clearly, right? So how do you achieve that? Well, there's a couple of different approaches. First of all, as you hire into your organization, I would suggest that you hire more consultants. Because they can come in and streamline the efficiency of your organization, but they're not going to write code. Also, they may take you out to lunch occasionally. Managers are really important. They're not writing code, but they get discretionary budget to hire more consultants. And the more budget goes into consultants, the less goes into actual programmers. Program managers, they help keep you on schedule. That's really important for clients to be able to see that there is a schedule to be kept onto. Product managers can go out and request feature ideas from the clients and then go back to them later and tell them what they got instead. That client communication model is really important for continuing to build the clients. HR is really important because if you're going to eliminate some of the programmers in your company, you're going to need somebody to fire them. And then finally, baristas are really important because who doesn't like more coffee? But I think it's important, it's not just about hiring more people, it's about also just hiring fewer programmers. All right, so I want to close with a little bit more. No, I'm not closing yet, sorry. Didn't want to get your hopes up there. I think it's also important to rest. It's not just about hiring other people to not write code. It's about figuring out how to write less code yourself for the actual programmers that are in the organization. So the amount of time that you spend programming obviously impacts the amount of code that you're writing, which means maybe everyone should be resting instead. Now, I like to rest in the rest room. It's sort of an obvious place to go to and hide from everybody. You can relax in the stall, you can play some games, you can really get some serious work done. And usually the conference rooms are all booked, so it's hard to get time for yourself there, but there's always room in a stall somewhere in the building. Productivity tools are really important for the developers in your organization. I find it important to provide multiple large monitors for the developers because if you get really nice displays, then you can have sort of full screen Netflix or YouTube on one while you're playing a game on the other. I like to provide the fastest machines available to the developers, again, because of the game playing experience. You really need a solid keyboard. And what I mean by that is not those like smooth, silent keyboards. What you want is one of the clicky, clacky ones that makes a lot of really annoying noise, because then everybody around you is going to insist that you stop typing. Noise-canceling headphones, obviously, to make the games more enjoyable still. Coding style is really important. We want to provide consistency. We want to provide readability. We talked about comments already. Line length is really important. It turns out that the longer your lines are, then the fewer lines of code you can have in your overall project. And fewer lines of code, you could squint and say maybe that means there's less code. So experiment with what works with you in your organization. And finally, readability is really enforced by having more blank lines. It provides more space, and it also provides more lines of code with no more logic whatsoever. So you get to bill more for providing more lines of code, but the level of quality is exactly the same as if you had provided fewer. So very powerful concept. So we've talked about comments already. Here's some data to support that. As the number of lines of code goes up, the amount of quality goes down. But as the amount of comments goes up, if you're writing comments instead of code. Now, this is an important concept. If you have a comment system like Java Doc or the equivalent in other languages, there's actually logic inside of those comments. I would hope that nobody uses those tools, because that means that you can break the build. You can actually insert bugs by writing comments, which I'm not a fan of, right? Just stick to comments, just stick to text. No logic whatsoever in your comments means no more bugs are going to be injected. And then finally, the number of blank lines. As that goes up, the level of quality goes up. And I think we can put these together with some other metrics and come up with a chart that looks something like this. And once again, I think this is obvious. In closing, I want to encourage everybody to practice and practice and practice best practices. Thank you.